Okay. Okay. Let's talk about a few questions. First of all, what is a DevOps? Any idea?
Yeah, more like you're streamlining the gap between development and actual operations.
Exactly. So streamlining the work between development and the operations. When you say development, it's the work of developer who will build the code. So developers will build the code in multiple languages like Java, .NET, Python. It could be any other thing, okay? Whatever they are comfortable with. Now, what this basically operations guy will do, basically, they'll simply deploy the code. As far as a DevOps point of view, before deploying the code, there is something needs to be there. The code is going to manage in where? SCM. What do you mean by SCM? Source code management. The multiple tools in the market, Git or GitHub or Azure Repo, like this, which will help to manage the code. You know, right? GitHub, you'll be having a code from where you fetch the code. If there is any changes in the code, the pipeline will get a trigger automatically. Okay. The next stage is as soon as you get the code from the developer, the code has to be trigger. Where it has to trigger automatically, if there is any change, the pipeline has to trigger. In Jenkins point of view, if you're using Jenkins, there is a concept called webhook. If there is a, if you're talking about ADO, Azure DevOps, then there is something option called trigger option. Sorry, just a minute. My kiddos are around. Okay. Once you have this triggering enable, then what do you need to do? The code given by the developer, we have to check the code quality. How you check the code quality? By using a tool called Sonar. Sonar Cube. What is the default port for Sonar? It's a 9000. Once you check the code quality, once the code looks good, then what you do? You're building the code. How you build the code? If the application is giving you the Java code, what is the tool that you're going to use? Maven. If it is a .NET, what you're going to use? MS Build or NPM. If it is a Python, what is the build tool that you're going to use? py installer. And for prerequisites, you use something called pin. Okay. Once the code is built and where you manage the code, next stage. Where you manage the code? We manage the code in artifacts. What do you mean by artifacts? The artifacts are like JFrog, Nexus. Do you heard this terminology anywhere?
Um, no, not really. Artifacts, no.
Okay, fine. You're understanding, right? Wherever
Yeah,
I'm
yeah,
giving
yeah.
an arrow, each is stage by stage. Okay. Now, after the artifacts, once everything looks good, then you have to run the test cases. Test cases given by the testing team. Okay. They will give you the commands because their code can be, their test cases can be in Selenium, Jacoco, whatever it is. They will give us the commands to run. Okay. Once all this looks good, your what the business analyst will do. Hey guys, code quality looks good, code looks good, test cases looks good. Now finally it is approved to proceed with the deployment. Now you can proceed with the deployment. Once you say you can proceed with the deployment is happening in Kubernetes. It can be happening in AKS. It can be happening in EKS. It can be happening in PCF, Pivotal Cloud Foundry. It can be anything. It can be standalone VM. Okay, wherever it is. So this is the exact flow from where, how you get the code, how you check the code quality, how you build the code, how you manage the code, how you run the test cases, how you deploy. This is the complete flow of CI/CD pipeline. You got it?
Mm.
So when interview point of view, pipeline stages. The stage one. What is the stage one you are going to refer is triggering. Triggering where from where it get triggered if there is any changes in the code. If there is any changes in the code, the respective pipeline will get triggered. Next, what is our stage two?
Quality.
Code quality, correct? And what is the tool that you're gonna use? Sonar. And what is the default port for that? 9,000. After that, building the code. The same step, whatever I've mentioned here, I'm mentioning it in here in short. Okay? Maven, MS build, npm, and after that you manage the artifacts where JFrog or Nexus. After that, you run the test cases and you do the deployment. That's how the pipeline stages. So as part of a DevOps tools, first you need to understand about developers work. How the developers gonna manage the code in SCM. Git concepts. What is the repository? Any idea?
Yeah, centralized location to
Exactly.
store
For
all the
my
code.
project, I can have a n number of repositories. What is the specific repository? Do I have access for that? If that particular repo is having the Java code, .NET code, Python code, what it is exactly. So you should have an idea first of all what is a repository. And once you are clear about the repository, then the next question will come into the picture: how to clone the repository. Now developers will not cannot do the changes directly on the master branch. When I say master, it is a production environment. It has to undergo the changes through a lower environment and then in the last it will go to the production. Okay, agreed?
Yep.
Development, QA, UAT, pre-prod, prod, and then so when you clone the code, you're gonna create your own repository, create a own branch so that you can make changes. Once everything changes is good, then you raise one pull request and you merge the code. Merge the code from where?
From the master repository.
Yeah, from feature to first you'll go with the development. From development you go to QA. From QA you go to UAT. From UAT you go to pre-prod. And then finally you go to prod. Depends on your how many non-production environment do you have. I am explaining you this because we have these many environments. We undergo the process. So you cannot make any changes directly as you are from application supporting, you know very well, correct? If
Mm.
your first job is talk to the change management team, you should talk to any changes to the application if there is any performance issues, why the change happened, what the change happened, why the change has not been informed in advance, why the backout plan has been not planned properly. Correct. These are the changes you're gonna ask to the operations guys if there is any issue with your application performance. Am I correct?
Yep.
Yeah. So now after creating your own branch, you make the changes. Once the changes are good, changes are going to track in PR, then merge the code. Changes will go from future, which is your local branch, and then to respective environments. Development, QA, UAT, pre-prod, and then prod. So once you're good with this, then once you know, for example, you have a code and you did some changes in it and you save the changes. Okay. After saving the changes, what will happen? There is something called commit ID will get generated. What is this commit ID? Refer to the changes. For example, developer asks you, hey, can you go ahead and remove this file? Can you go ahead and edit this file in this particular line number? I don't want this content because in the application point of view, I don't want to see the tab itself. Maybe some changes. XYZ, you know, you are not doing a role of developer here. You are just following the suggestions and doing the steps as per the development suggestion. So commit ID will help you to refer the changes. What was my code previously? What was my previous code next? You got it? Commit ID is like a ticket number. What was your code previously before the changes? What is the new changes? That's called a commit ID. For example, there is a developer. There is a developer. He has worked from Monday to Friday. Okay. Monday, he worked on the changes. The commit ID 1. And Tuesday worked, got a commit ID 2. Thursday, commit ID 3. Sorry, I forgot about Wednesday. I'm just trying to give you some example, okay?
Yeah.
Friday C5. Now imagine if the developer, Monday he did some changes. Monday he raised a commit. Monday he did a push. And then Tuesday he did a push. Every commit you need a push. But imagine if you have a five developers pushing the code. That is a clumsy environment. I don't want each commit by developer. I want, hey boss, don't push the code on day-to-day basis. For example, if your T1 task is completed, if the T1 task is having a multiple commits, can you push all the commit IDs combined together as part of a particular task? For example, T1, sorry, you can consider as a W1, which is a week 1. Week 1 is equal to C1 plus C2 plus C3 plus C4 plus C5. You got it? Now, developer is not pushing the everyday code. He is going to push the 1 week code. How you combine the multiple commits into a single commit? Stash. There is something called concept as git stash. Okay. What this is going to do? Combining multiple commits into a single commit. There is something called git reset, revert, rebase, merge, squash. I'll write stash also. Squash, stash, You have a multiple options. Now, what this reset will do, what this revert will do, we'll see in the lab going forward sessions.
Okay.
Okay. So I'm just trying to
Yep.
help you here in terms of the work of a developer. Are we going to do the job of developer? No. Even though you are not doing a job of developer, you should understand what the developer does. Why I need to understand what developer does? Because developers will ask you to do some changes. Developers will ask you to raise a pull request. Developers will ask you to push the code. Because it's a continuous process. You cannot say I can't work with the developer because he is coming daily basis. If that is a really problem for you, then don't plan it for daily, plan it for a weekly. Simple. You
Mhm.
got it?
Yep.
So, any questions in terms of Git concepts?
No, it's pretty clear. I mean, I use Git extensions,
Yeah.
but that's primarily just to push and pull code. There's no merging or stashing done. Very low development, you can see, like one push in 3 months.
Yeah, yeah. Okay. So I'm just giving you the overview today of each and every
Yep.
technology. What does it do?
Yep.
Will continue in the further sessions for a lab. Okay. What is a
Okay.
Docker? Any idea what is a Docker?
Yeah, it's just like a, in short, it makes a portable version of your application, which can run anywhere.
So Docker has come up with a concept of called images. Images will have its own lightweight protocol, own operating system in terms of a container. When you run the image will convert into a container. Container is considered as a machine. Lightweight protocol which is having its own operating system. Okay. You name any technology, that particular technology image will be applicable. Any banking sector, any healthcare, any retail, images are available. The overall concept here is you need to learn is how to pull the images, how to run the images, how to build the customized images. Why the customized images I am stressing?
Mhm.
Because sometimes application teams say, hey boss, I don't want the default image which is available by Docker. I want you guys to create a customized images. What is the option for that? Docker build hyphen T and then the Docker file name. File name with extension of Docker. There is some inputs will be there. We'll see in the lab. Okay.
Okay.
Now this
Yep.
customized images, what is going to happen? They're going to manage in a private registry, not in the public registry. Public registry is something which anyone can access, anyone can do the changes. Whereas in private registry, that is not possible. And there is something called volume concept. We'll discuss this while doing a lab. Okay. What is the next? Terraform. Any idea what is a Terraform?
You build your VMs through code.
Say, for example, when I say deployment, that is actually a war file deployment, which we call it as an application deployment, which means I need a deployment. I am writing a code for this application. In the same way, if I need an infrastructure, I can write a code for that also, which means code
Mm.
is not only used for building the application, code is also used for building the infrastructure. You got it? When I say infrastructure,
Yep.
it's a VM, VNet, subnet. It could
Mm.
be anything. Okay.
Yep.
That's what we're gonna cover in a Terraform. Once you're comfortable with the Terraform, what we will do from Terraform to AWS, Terraform to Azure connectivity, we're gonna check. if you run any code in your machine, is that really gonna push the on your machine? That's what we're gonna see.
Mm.
Now, see, we have covered Git, we have covered Docker, we have covered Terraform. What is that next? Kubernetes. What is this Kubernetes have the most resourcing components? Pod, replica set. Hello.
Yeah, yeah. No, I've not come across complete of Kubernetes.
Okay, okay, okay. I was thinking that good connection got disconnected. That is fine, absolutely fine. Pod, replica set, and then deployment. Okay. What do you mean by pod? Pod is again having images. Once you run that image is having a container again. What do you mean by replica? You have seen the Rajnikant movie called Robo.
Mm.
One robo can make another robo, correct?
Yeah, yeah.
So in the same way, replica means a duplication. If you
Mm.
decided I need three replicas, if one replica goes down, one pod goes down, the other two will manage the traffic. And one pod goes down, in that case, as part of Kubernetes, auto healing facility is there. This pod will restart automatically, even though it is something down, crash, or whatever it is. You got it? Auto restart
Yeah.
is available with respect to pod. So
Okay.
observe for a while and then you take a decision. Either you have to go with the old one, either you have to go with the new one. So once you are clear about Kubernetes, so we covered Git, we covered Docker, Terraform, Kubernetes. Next, the main major is Azure DevOps pipelines. Why we need Azure DevOps pipeline? If you need Azure DevOps pipeline, first you have to start with where? SCM. Once the code gets in, once the code build, convert the code into image, that's where we need a Docker. Once the
Mm.
image is built and converted, and then that particular image, whatever you're talking about, is gonna push with the help of either application deployment or infrastructure deployment. It could be anything. By using Azure DevOps pipeline, you can create application deployment or infrastructure. Mm.
So Azure pipeline that you say is kind of a version control system in Azure.
Sorry, what was that?
No, you said Azure pipelines. Is that some kind of a version control feature within Azure?
Yes, yes, Azure repos concept I told you, right? Azure repos is something here. Code quality SCM. Yeah, see here. GitHub, Azure repos. All three
Okay.
works the same way. For
Okay.
example, if the developer is giving you the code, imagine that is a version one.
Mm.
If the business analyst asks do some changes and developers did it and they push the code, and the new version of the code will become version 2. Again, the code will be managed in same SCM, source code management, which is GitHub.
Mm.
Basically, 99.99% managed in GitHub only. Okay, so this is the overall demo point of view. I'll show you a quick walkthrough of the documents.
Yeah.
My my way of explanation will be exact content. I won't waste your time anywhere in theory. Okay.
Yeah.
So you see what is a DevOps? Development press operations, development integration, development testing operations, CI/CD tool. What is the stage name? What is the purpose? What is the tool they're gonna use? For a code validation, you use Sonar. The purpose is code verification. For building the code, what do you use? Maven, MSBuild, PY installer, Gradle, and this Maven, Gradle, and is for Java. This MSBuild and MSBuild is for .NET. PY installer is for Python. Where you manage the artifacts? Artifacts you're gonna manage in a JFrog. What about the testing? What about testing? You like JUnit, Selenium testing, NUnit, PyTest approvals. Business analyst because he is the guy who is a critical resource. He talk to the investor, solution architect, and get the requirement, give it to developer, and convert that the business requirement into the stories. Then thereafter, developers will build the code. Correct?
Yep.
That's how the real time situation goes.
Mm-hmm.
And after that, where is your actual deployment is happening? It's Kubernetes, PCF, all those things.
Yep.
So it's again Java, same Maven, Gradle, .NET, Python, PY installer, all those things. And you know sprint. What is a sprint?
Yep.
Sprint is basically a 2 weeks a time frame where again there is a poker session will be happening. During the poker session, what this business analyst will do? Hey, developer, how much time you need? Tell me for this task. I am not going to decide. You please decide. That's a agile terminology. But once you are committed that you are going to deliver in 2 weeks, honestly, believe me, you are committed means you are committed. Then there is no other second chance. You got it?
Yeah. Yeah. Yeah.
So if you are committed and if you're not able to deliver, then that will be considered as a backlog for your next sprint. Again, you have to do the task of a new sprint plus old sprint also. So that is a big issue. If you don't know, raise your voice. Don't say yes when you don't know. Simple and clear.
Mm.
What is SCM polling? Webhooks, we have already discussed it. Webhooks, we already discussed it. Webhooks is like a automation kind of stuff.
Rather than you application polling, it tells when there's a change.
When you do the triggering, when developer does any changes, the webhook will happen and pipeline will get a trigger, all those things. Okay.
Yep.
So how the stages looks like. See, the beauty here of DevOps is you are not going to write the code anywhere. Don't get panic by looking at the scripts. You are just knowing which stage is doing what and you are going to run the pipeline. You are not in 2020, you are in 2026, which means the code, the pipeline, everything is already there. You are just running it. If there is some issue, you are managing it out. That's it. Okay.
Mm.
For Kubernetes, you have a YAML files. For pipelines, you have a pipeline stages. If you just know how to, which stage is doing what, that is more than enough. Okay. Repos, pipeline, artifacts, boards, test plans, all these things.